that go inside of HoloLens. So let me break apart the display engines, this thing that we invented with HoloLens 2. The technology behind it is called MEMS, right? And these are laser displays. We moved away from HoloLens 1, where we had LEDs. It was an LCOS-based system, to a laser-based system. It gives you tons of benefits because lasers are like coherent light, right? It's very digital for a format. It's either on or it's off. It's not a nice bell curve, which is what you get with LEDs and things like that. So then the idea is we have 3 lasers. Imagine it's one of these for each of your eyes. So there's 2 of these in a HoloLens. So 3 lasers, 1 red, 1 green, 1 blue, right? With red, green, and blue, we can create essentially any color on the palette. Well, we shoot lasers out, red, green, and blue. One photon, just a second, and I'll go to you. And then we hit essentially 2 mirrors. First, we hit a fast scanning mirror, right? By fast scanning, I mean it goes at about 12,000 hertz or 12,000 times per second. The purpose of that mirror is to take those lasers, just 1 photon, right? And spread them across the horizontal part of the display. And then those lasers hits another mirror. We call it the slow scanning mirror. It only goes at about 120 times per second, which will then squirt those same photons in the vertical, right? Thus creating a virtual display, right? If you think about an LCOS system, you actually have light behind each of the pixels across the entire array, which defines the actual resolution of that display. In this case, we just have single lasers, and we build in real time, right, what that display looks like. As a matter of fact, we're going to build that on the back of your eyes, which is how you ultimately see a hologram. Go ahead, sir. No, we don't. So the question, I'm going to repeat it because I'm not sure people online can actually hear a question. The question was, do you have problems with laser speckles? Obviously, very good question. All laser speckle. I'm not going into all the detail of all those pretty little mirrors, but there's one there that actually despeckles the lasers. And I actually played with it because at first I'm like, maybe you don't want to despeckle the laser because wouldn't it be cool if, like, as you look at a hologram, it has sparkles. Maybe holograms are made out of diamonds. But it didn't actually look very good. And so there's pieces inside this infrastructure to actually despeckle the lasers before they do what's called couple-in optics, which is when they couple in with our SRGs, which are the lenses, which I'll talk about in a little bit, that this thing goes into. So that's a little bit about the magic of the display engines. MEMS-based technology, 3 lasers, red, green, and blue. One hits a fast scanning mirror at 12,000 times per second, and then hits it, another one at 120 times per second. Now, to put it in perspective, here's the actual photo. The previous one was just a rendition. This is the actual thing. Now, this is under a microscope, right? If you actually were to see this mirror, they're teeny tiny. This is actually our functioning, fast scanning mirror. Clearly, if you try to take a picture under a microscope at 12,000 times per second, you don't get to see a modulate like this. So this is taken with a special camera under a microphone and super slowed down for you to have an idea. Basic principles here, imagine I'm applying electricity, alternating electricity to both sides to essentially stimulate this mirror to get to the right frequency when you actually boot up every HoloLens. Now think about the precision of that as the device is moving up and down, as you're dropping it on the floor, as you're doing any number of other things. Where if you get this, more than a little bit off, and by little bit off, think like, picometers, the whole thing doesn't work. And there's no holograms for you, right? So think about the precision that you need to have in both manufacturing and in-field calibration to make sure that the device actually does what it's supposed to. MEMS mirrors as a technology have existed for a while. There's no new big invention on that topic. To be able to ship it in a product at this scale, at this size, at this resonant frequency is something that has not existed on Earth before. So that's a little bit about the displays. Now, these displays